Okay, welcome. Today we're going to look at performing operations on radical expressions and then simplifying the results. So go ahead and take your notebook out and get ready to take notes. Remember, you can stop the video if we're moving too fast, or if you don't understand the concept, rewind it and listen to it again. The textbook section we'll be working out of is just a small piece of section 4.5, and it's a precursor to solving quadratic equations by finding the square roots, which we're heading to down the road. Okay, let's look at some key vocabulary, and bear with me, I'm writing with a tablet and I'm doing my best, so here we go. Okay, some of our key vocabulary we need to look at are, well, first of all, let's take a look at this symbol. We've known this to be called the square root for a long time, but it's essentially called the radical. So from now on, we're going to refer to this as our radical sign. Okay, radicals usually have a number sitting up here that is referred to as the index. So that is our index. Now the index is a very important number to know when we start simplifying, so be aware there is a number. With the square roots, however, the index is understood to be 2, so we never actually write 2 there for the index. The number under the radical is called the radicand, so we'll call that, or expression, we'll just call that guy A. So we have the symbol called the radical. We have the number that sits right up in here, that's called the index, which is essential for simplifying. And then we have the radicand. Okay, so as we move to simplify our radicals today, we're going to run into some techniques called rationalizing the denominator using conjugates. Rationalizing the denominator using conjugates. As we move toward those examples, we'll talk a little more about what those are. Rationalizing the denominator simply means we cannot have a radical in the denominator, ever. So we rationalize it to get it out of there. And we use something called the conjugate to do that. Okay, let's kind of move on and see how we're going to do this. We have some properties, and I'm going to quickly go through these, but we're going to look at the product property and the quotient property. And the product property basically says that if I'm multiplying two radicals together, I can rewrite them multiplied together under the same radical. Or I can take a radical and split it up into two separate radicals being multiplied together. For example, 18 can be rewritten as the square root of 9 times the square root of 2. And we all know that 18 square root of 9 simplifies into 3. I could also go backwards and say square root of 9 times the square root of 2 is equal to the square root of 18. Our quotient property basically says if I'm taking the radical of a fraction, I take the root of the numerator and the root of the denominator, whatever those are. Example would be a square root. The square root of the square root of 2/25 is equal to the square root of 2 divided by the square root of 25, which is the square root of 2 over 5. Now, we're going to look at some examples and actually work them out, so don't get hung up trying to copy these down. We're actually going to see how they work in the next example. But be aware we have the product property and the quotient property. Okay, let's go ahead and first start with simplifying. Let's start with the square root of 80. Okay, to simplify the square root of 80, the first thing I notice is it's not a perfect square. There's no number times itself that equals 80. So the way we're going to handle these are we're simply going to do a factor tree and rewrite 80 as a product of primes. So I'm going to go over to the side, take 80, and do a factor tree on. It's going to be 2 times 40, 5 times 8. And I know 8 is 2 cubed. So I can say 80 is equal to 2 to the 4th. Let's count them. 1, 2, 3, 4 times 5. So rewriting our radical, 2 to the 4th times 5. Now since my index on a square root equals 2, and again it's a number that sits here, but we do not write them with square roots, I want to make everything inside to the power of 2. If I can do that, I can rewrite everything underneath the radical, the radicand, everything in the radicand, to the power of 2. I can take the square root and move it outside. So using our exponent properties, I know 2 to the 4th is 2 squared times 2 squared. And again, there's my power of 2 times 5. So remember, product property, bases are the same. We're multiplying, you add the exponents, 2 plus 2 is 4. That being said, since both of these have the power of 2, I can simply move them to the front. So this would be square root of 2 squared times the square root of 2 squared times the square root of 5. So when I say move them to the front, I'm really simplifying. There's 2 times 2, and square root of 5 just comes down. And we know that two times 2 is 4. So this simplified is 4 square roots of 5. And the key was rewriting our expression, our radicand, to powers that match the index, and that's what we did here. They match the index. It means we can take the root of them, as we did here, and we are simplified. All right, let's take a look at the next example. Go ahead and write down the cube root of 6 times the cube root of 8. Excuse me, the cube root of 18. Okay, we're going to do a similar thing like we did in A. The first step we're going to do is we're going to write them using the product property under one radical. We're going to multiply them together, but don't actually multiply them together. So the cube root of 6 times the cube root of 18 is the cube root of 6 times 18. We're going to take both of those numbers, do factor trees on both. So let's see, that's 2 times 3. And that's 2 times 9, which is 3 times 3. Let's bring him down. So 6 times 18 is actually equal to 2 squared times 3 cubed. So I'm going to rewrite this radical as the cube root of 2 squared times 3 cubed. Notice, again, I'm looking for our powers to match our index. In this case, our index is 3. So if I have a power of 3, I can simplify it or move it to the front. So rewriting using the properties of exponents, I'm going to write our 3 cubed first. So this is the cube root of 3 cubed times the cube root of 2 squared. These guys are inverse operations, so they go away. And I'm left with 3 times, and since he's 2 squared, 2 is less than 3, so he stays underneath the radical. So I'm going to write him back as the cube root of 2 times 2, or 4. And now we're simplified. Okay, these examples are very similar. The only difference is when I performed the operation of multiplication, I rewrote them under one radical first to make it look like the example in A. From there, it's simplifying by using our factor tree and trying to locate powers that match the indexes, 3, 3, and so forth. Okay, let's take a look at our last example. So we've done just straight simplifying, we've done multiplication. Let's take a look at dividing. And we want the fourth root of 81 over 16. So using our properties, we're going to rewrite this as the fourth root of our numerator, which is 81 over the fourth root of our denominator. Now the fourth root of 81, we're going to handle it separately from the fourth root of 16. So again, I'm going to do a factor tree, just on the examples. And again, I'm looking for powers of 4. So this is 9 times 9, which are 3 times 3. And we can see that 81 is 3 to the 4th power. There's a power that matches our index. So we'll be able to simplify this to just simply 3 in the numerator. Doing the same thing with 16. 16 is 4 times 4. And the 4s can be simplified down to 2's. So 16 is 2 to the 4th power. And again, our exponent matches our radical. Since these two match in both numerator and denominator, we can say that the fourth root of 3 to the 4th is simply just 3. And the fourth root of 2 to the 4th is simply just 2. And there it is simplified. Okay, we've now looked at simplifying, multiplying, then simplifying, and dividing, then simplifying. Okay, make sure you take good notes on these. If you have any questions, write them to the side and we'll answer them in class. The last set of examples I want to look at are the rationalizing. We said earlier when we were talking about vocabulary that we cannot have a radical in the denominator. So how do we handle that? Let's go ahead and take a look. Okay, let's start out with the example A, the square root of 5 over 2. Okay, writing that down, I get the square root of, trouble with my pad here, hold on. There we go. Okay, I'm back. That's the square root of 5 over 2. Again, by the property, it's the square root of 5. over the square root of 2. And notice that I can't simplify these. Square root of 5, there are no perfect squares in there. Square root of 2, there's no perfect squares. In fact, they're both prime. But I have a denominator in the radical. Okay, I can't get that, so I can't have that in my answer, so I must rationalize. So to rationalize, we're simply going to multiply both numerator and denominator by a radical that will make the denominator go away. Now this is 2 to the first power, and what's going to make that go away is 2 to the second power. I need another square root of 2 here. So if I multiply top and bottom, or this radical by itself, and the same thing to the numerator, the square root of 2 times the square root of 2 is the square root of 2 squared. The top becomes the square root of 5 times 2. The square root of 2 squareds, they're inverse operations. The indexes match, so I'm left with simply 2 on the bottom. 5 times 2 is 10. Can't be simplified any more than that. And I get the square root of 10 over 2. Okay, so again, it's all about getting out the radical out of the denominator. Again, I'm learning to use my tablet. Okay, lastly, let's take a look at how do we do example B. Right, so go ahead and write down the 3 over 7 plus radical 2. And this is actually dividing, and I'm dividing by a polynomial. So here we go. Okay, so again, I cannot have a radical in the denominator. I must rationalize. Now how I rationalize is known as the conjugate. Because this is a binomial, the only way it's going to get rid of that radical is not multiplying by itself, or the square root of 2, by what we call the conjugate. And the conjugate is very similar. It's got the same first term and the same last term. Remember what we do to the denominator, we do it to the numerator. And the only difference lies in the sign in the middle. Because that's plus, we're going to go minus. This is called the conjugate. Now if we think back to factoring, we can see that the reason we need the conjugate is, well, when we multiply these together, 7 times 7 is 49. 7 times negative square roots of 2 is negative 7 square roots of 2. Square root of 2 times 7 is positive 7 square roots of 2. And square root of 2 times negative square root of 2 is negative square root of 2 times 2, or 4. Now the numerator, I'm going to simply, at this point, just put them together, not actually multiply through, because we may be able to reduce. As I mentioned before, if we think back to factoring, the reason we use the conjugate is we need the middle terms to go away. The middle terms are the two terms that still have radicals in them. If they go away and simplify the square root of 4, which we know is simply just 2, we can rewrite this as 3 times 7 minus the square root of 2. Again, don't multiply that through yet. We want to see if we can simplify it. These two terms, like I said, are gone away. I'm left with 49 minus 2, which is 47. Again, no radical in the denominator. It's been rationalized by using the conjugate. The last thing I look for is, can I simplify this? Does 3 go into 47? Doing some quick math in my head, I don't see that happening. So I can, at this point, distribute through 3. I get 21 minus 3 square roots of 2, all over 47. Okay, this last example is probably the toughest of all the ones we did, but is one of the most important. Make sure you understand what's going on. Try to follow it step by step. If you got lost somewhere and you listen to it again and are still lost, jot down a note and we can take care of it in class. So make sure you understand these two examples that we did, A and B from example 2, and make sure you get the idea of what's going on with simplifying the radicals of higher power. Okay, bring these to class tomorrow and I will check your notes to make sure you did actually watch the video and give you points for it. And we'll do practice in class and answer any questions and be ready to move on. Thank you and see you tomorrow.